So I start. Yeah, I guess I start. Thank you for setting up everything. Thank you for joining here, and also those who are watching online later. And today I want to explain about confidential computing in Web3, especially how we do that at Flare. And yeah, like blockchains essentially are excellent and very good in transparency and making it everything verifiable, but sometimes you don't want to be public. Let's say, for instance, some couple of examples would be user data, business logic, some kind of specialized strategies, compliance checks, or cross-chain interaction, or some kind of sensitive off-chain data. You want to keep it private. You don't want to expose it. And then there is question, how can we keep this sensitive computation private? You can come in closer, otherwise you won't see the code later. So how can we keep this sensitive computation private, like how we execute something, but still have proofs and trust and verification on chain? And this is where Flare confidential compute, or TEs in short, comes in. And I will give you a short presentation, and then we will actually see the code, how it works behind the scenes. And before I go deeper into Flare confidential compute, let's take quickly a look what is Flare. So Flare is EVM layer 1, and it's designed around data. And the core idea is that contracts can access data from other chains, let's say prices, events, proofs, messages, and also Web2 data. And we can clearly say that Flare is blockchain for data if you need to process that kind of information. And Flare confidential compute especially extends this idea with data, because we can bring data on chain, not only read, but also write, and do it in sensible private manner, and have proofs back on chain. So basically results are relayed back on chain. And quickly about Flare confidential compute. So that, like I explained, adds this confidential execution layer to Web3. So basically sensitive work happens off-chain when you don't want to expose like private keys, API keys or something, or maybe some you have AI models, what are you running there, you don't want to expose, and also you have much more power than it is on chain. So you can access better machines for your tasks. And then everything is anchored back to chain. So there is integrity, identity, verification. So that comes back on chains. And developers can build applications where private stays private, but like computation still is in isolated environment. So that is the TE. And blockchains just receive sign actions, instructions what are sent to the chain, and then relayed back. And I think this is quite powerful, because we still get qualities of blockchain, and we can extend it and do it in actually very safe and trustless manner. And I want to explain that, stress that Flare confidential compute is still in latest development stage. It's on testnets. And yeah, so today I will give a sneak peek. It might change maybe slightly, but we are close to mainnet as well. So and right now we are getting like feedback. We had first hackathon, so yeah, I hope it will spark some feedback today as well, or tomorrow in this conference. And how it's kind of tied together. There is everything is Dockerized. There is T node, T proxy, which is relayed information from blockchain to Ts. But the main thing what developers need to worry about or need to develop essentially are Flare compute extensions. So we can say that these are small applications in T environment what runs inside these T machines in a secure enclosure. And thing is that these extensions, they don't have access to outer world, let's say. They have access only inside, so they pretty much get instructions in asynchronous manner, then they process these actions, and then they post results. So they don't have access to the blockchain itself. So that's behind the proxy, which signs all the transactions. And yeah, we can have like small comparison. So basically, smart contracts are deterministic and public, but Flare confidential compute extensions extend these smart contracts into workflows, into confidential private off-chain execution. So that's, I think, it's very powerful. And yeah, the mental model, I think, is public settlement but private execution. So public settlement, and thing is that all of this is with saved with the consensus, and basically all the instructions to E are relayed with 50% signature weight from data providers. So they you get same proof. I mean, same security as system, Flare system itself, the network. And yeah, so that so we can think about these extensions, that those are like notary, that you can prove that some that notary kind of signs like document, but they not always expose what's in the document. So for instance, you want to know that if person can, you know, buy alcohol, let's say, very stupid example, but that's the most simplest one. And you need to know only if that person is above some kind of threshold age. You don't need to know their name. You don't need to know their exact age. You just need to know that that's like above this threshold. And notary signs, notary says, yes, you can sell to this person alcohol, and that's how these extensions work. So the proofs are still relayed back to the chain. And today I want to explain, I want to show a demo. So we look into more, and this demo is weather insurance. So basically, you came to this conference. Hopefully today won't rain, but actually yesterday and day before it was raining, and you buy insurance. So if it rains, you get money for taxi to come to this conference. So you don't need to come here, you know, soaking wet. So yeah, so that's the application I will be showing. So let me uh, so this is the front-end application I will be showing. We will go into details how it works behind the scenes, and a couple of things to set it up, as it is insurance application, is we need to have some kind of pool. In this case, that pool is by multiple people. It's just a pool, and it uses mocked ERC20 token for simplicity reason, because that's not the main point of this demo. But here is the you know, the real meat of this demo, is that we want to buy a policy, and Here I have two options, which is private and public, and we will look into today only in private. And how it makes everything private is that the signing mechanism is using ECIES mechanism. So basically, TE has a private key, and it exposes public key. So this is the very important how you can encode information and send to TE, and that TE has only this key, and then it can encrypt it. So that is very, very important. So it exposes public key. You can get this public key with GET request through the TE proxy for this specific TE extension, and then encrypt information, and then you know that no one else can encrypt this information because only the key is in TE. And important is that this key is in TE, so basically no one else can alter that. Otherwise, the hash of this TE is not correct, and all of these hashes are in TE registry on Flare blockchain, so you know that you are interacting. So basically, when you send interaction, we will check how it's from the code. This interaction won't be relayed to the TE, so the kind of integrity checks are not in place. But the thing is that TE, as it is trusted execution environment, is in secure enclave, and no one can, change it. So once you deploy it, it's there. And yeah, of course, there is a problem that what happens with the T goes down. So pretty much there is no state. There can be some workarounds, but I will not go into details in this demo. So we are actually currently exploring these mechanisms. Redundancy, that is, problem as well. Oops. And yeah, so then we can buy the policy. I will go into details, and then I created the first demo feature, which is getting live weather. So this application, where it gets weather, it gets from Open Weather Map API. We can argue if that is legit or something, but that's one of the best out there. And this is how we can, so the mental model how to get weather is from this Open Weather Map API. And let's say we want to get weather for Berlin right now. So what it does is that it constructs, I will jump into the code quickly. It constructs the request that it will be sent to TE. And as I explained, TE works in asynchronous model. So as you saw, there was small delay. So instruction is sent to TE. Basically, you say to TE, hey, please check weather. That's what you essentially say. And then TE does it work. In this case, it was a couple of seconds, but if you are working with like AI models or such kind of things, then of course it can take more time. So you need to see when this instruction has been processed. And we can see that currently it's almost 18 degrees and scattered clouds. So hopefully it won't rain today. So let's go into code. So here I will not show everything, but some parts. And code, of course, we have on our GitHub. I will show the post the link in my X as well. So everything is open right now. You can download and check it out later. But this is the smart contract, how when you call getWeather, it interacts with this specific function. So what it does, I will make it a bit bigger. What it does is that it gets the TE from registry, and in this case we are getting just one T machine, so we are not using multiple, but for redundancy actually it could be more than one as well. The important one is that we are using extension ID. So each of these small applications have their own ID, but there can be multiple machines who are running this extension. We have cosigners feature as well, but in this demo I'm not using cosigners, so that's another layer of security. And then we are constructing the T instruction parameters. So essentially that is a struct which says what is the operation type. In this case that's weather, and what's the command. And then we are encoding a message. So message is arbitrary data what T will encrypt. I mean decode. And then we send that instruction to T registry, so we have all the necessary information. What's the T ID, what's the extension, what's the message, and then we send to registry. And then the Flare network, like validators, they see, okay, that's like valid instruction. All the hashes match, and then they can send, I mean, the T proxy can pick it up and see, and I mean, relay to the T itself. Come closer, then you can see code there. And let's go to the extension itself. In this case, extension is written in Go, but pretty much that's like web service, and you can use TypeScript, you can use Python, whatever language you like. And here we have a bunch of here is the config file where we are configuring these types, which is operation type weather, and then multiple commands. In this case, we just executed fetch, but then we will look into how we buy policy as well. And then the extension itself. So what it does essentially is that T proxy sends requests, and then it processes the actions. And in this case, we have just one action, which is weather. And then here we have a function which is processing the weather, and then multiple commands. And here what's important is that in this case weather fetching. So we can scroll a bit down, and what happens here, there are a bunch of checks. If we check if there is open weather API, if message is fine, but the most important here is that we are actually fetching the weather, and that lives in this utilities file. And what it does, it's actually not so interesting. It goes to open weather map API, and it fetches weather. Those who are in back, you can come in front, otherwise you won't see anything. And once that is done, then we have the report of the weather, and then we are constructing a result. And the T proxy signs this like result. So then we can see if that is that came from this T. But I think that's like very simple. But let's try and buy policy with this application, and then go into more interesting flow. So let's say we will buy, for instance, for Sunday. In this demo, of course, we can buy from backwards, but of course, in real application, it wouldn't be the case. And here, what it does, it approves these test tokens to buy the policy. That's not so interesting, but here all of this cryptic thing is that it tries to buy policy in private manner, and we will go into code step by step. So let's hope everything works. So that executed, but now we need to relay back to chain the result. And I will go into step by step in code what is it is behind the scenes. So don't worry. And here we have Berlin. We haven't settled that policy, but let's go into code how it works behind the scenes. And so here we have smart contract, and let's go to to this function, which is buying policy in private approach. So basically, how it works behind the scenes is that once we specify the minimum rainfall, so basically, if it rains more than 1 millimeter, we will get the payout. But we don't want that everyone would see this minimum rainfall of millimeters. We want to encode it. And as we see in this list, that is hidden, like these millimeters is hidden. How it works behind the scenes is that we know the extension, that specific extension, we get the public key, and then we encrypt this information. So only the TE can encrypt it. And that is what we call here. So this is encrypted policy. And again, like I explained before, we get the T from registry. So in this case, we have just one, but we can have multiple machines running the same extension. We're not using cosigners. And we're executing operation type weather and command by. And we're sending this encrypted policy. And then we're sending to registry, so the validators can validate that everything is fine. The T hash is still intact, it's valid, and then it's relayed to the T confidential compute. And then we need to go to extension, and here let's jump to the buying policy privately. So what it gets here? It gets here the private buy parameters. So remember, we encoded with private key. So basically, that decodes that information. So now because the T only can decode because it has this private key. And then it gets all the parameters like date, premium, payout, what we had here in this front end. So it gets all these parameters. And it creates commitment. So commitment, in this case, it is hashed information that we can relay back to blockchain. So then blockchain can reference what's in the T memory. So T is not exposing the this millimeter threshold. So it has the hash of this policy snapshot. So that is what is relayed back to chain. So then once it's done, it tells that, hey, I have the result, go and, we can see that that result is published. It's again in asynchronous manner because it can, here it's very, very fast, but it can take more time. For instance, if you are working with a model predicting weather or something, then of course it takes time. And then secondly, you saw another transaction. So that is finalizing private buy. So pretty much anyone can execute that. And let's go into code what happens there. So then when we're relaying back the private buy, we have the data from the T instruction result. we have the action ID, we have all the necessary information, and we have the signature of this TE as well. And then what it does is that it reconstructs this result. So we have the result data. Remember, that was hashed information. Then we have a submission tag, and then it's very important because it checks that from which TE this instruction came. So if you are trying to feed some malicious information, then the signatures are not, like working. So the signatures are wrong. So basically, that information could be signed with not correct key. And then we are saving this information on chain, like all these parameters, what's that payout, rain threshold, all that stuff. And then we are creating policies. Then we get the policy ID, and we are not exposing the in this list the what's the rain, what we are buying the policy, so no one else can see it, or they can see what I'm working on. So we have only the proof on chain. And now we can go and settle this policy. So basically we want to get the payout. We know that it was raining. And again, I will show from the UI and then go into the code. So what it does, it requests the settlement for this specific policy, and then we get back the. It's relayed to the T, and what T in this case will do, it will go and to Open Weather Map API and check if there was rain. And we can clearly see that there was 3.44 millimeters rain measured in Berlin this Sunday. Then we get back 10 tokens for our policy. So we bought for 1 and we got back 10. So this very simple how insurance works behind the scenes. But let's go into code where we have all the interesting stuff. And here I'm in smart contract. So first we start calling this function request settlement with policy ID. Then it gets the policy from the policy registry array, checks that there is this policy, it's not settled. We can settle after a specific unlock. In this application, I said that you can settle policies which are for previous day or after 6 p.m. Today. Otherwise, there is no data for today yet measured, rain. And then we are getting the TE, like we did before. And constructing the message. And in this message, we have policy ID. We have address who is settling this policy. Then we have date, latitude, longitude, and commitment. And remember that commitment is hashed information of this millimeters of rain. So we are still not exposing to publicly what it is, because maybe someone can intercept it in between before our policy has been settled. And then we send this instruction to TE. And I want to stress again that T's work in a synchronous manner. So you send instructions, they process it and return result. And then using proxy, you can see that, okay, this instruction has been processed. And then we send to the T registry. Again, all the network validators validate that this is correct. It belongs to the correct T. The code, the hash hasn't changed. There is a T machine running. All that is what network validators do. And let's go to extension. Again, I explained that this is in Go, but it can be in different language as well. So we need to find that this process whether settle. Yeah. So we have this function. So basically that gets the processing the settlement. So basically starting the settlement. Then we have a bunch of checks if we have API keys. And then we are decoding the settlement message. So then we get the latitude, longitude, basically location, date, all that stuff, which we are saving here. And we need to untangle the private terms. So now we have the hash, we have the terms commitment, we have them inside in the memory that no one else can see. These millimeters. So we take the hash and we get the correct millimeters. What we need to see if that insurance we need to pay out. So still is not visible to anyone. And then what it does is that it fetches day summary using Open Weather Map API to get the measure precipitation, I mean millimeters in rain, in short, from the API. And that happens here. And it's I would say nothing interesting. Is just a API get call with specific parameters and API key, which is not exposed as well. So this API key is only it's private in this T machine, so no one else can see it, no one else can read it. So that's for you. And I think yeah, it's very powerful. And I will talk a bit later other use cases where it could be even more powerful than this simple application. And once that is done, we have the revealed threshold of millimeters, and then we are creating the settlement result. What was what we get back from the Open Weather API. And then once that instruction is, I mean, this process has finished, it tells, hey, I have finished this action, and then we can get from T proxy, okay, this is finished, but we need to relay back that to chain, and that's why you saw two transactions. And in this second transaction is being called settle function. So we have the result data what comes from TE. We have action ID, and then important is signature, because signature what comes from the TE. And then if all the signatures match, so basically we derive the signer from the from this data. If that matches, so basically this message is from correct TE. Then we can write this information on chain. And in this case, we are decoding the information from the result data, the policy ID, what's the millimeters, what's the date, and what is the revealed threshold. So basically, what we how we bought the policy at first place. In this example, I made that after the policy is settled, we can see what was in this policy, what the user specified. But of course, that could be actually private information as well. It's just for the demo that we can all see it. And we are updating the storage, so basically everything is on chain. So what you see in this front-end application, it comes from the chain. And yeah, here is the check. If it's private commitment, then we are revealing if everything is fine. And yeah, then we update the array on blockchain and emit settled event. So this is how it works from the code. And yeah, so we in this application, which is open source on our GitHub, I will post the link on my X, or you can find on Flare Network GitHub, and we can follow along everything. How we, for instance, bought this policy. So we can see that we bought for one token, and of course we can see that it's settled, and we get back 10 tokens. So it was raining. We came to the this conference. We're soaked wet, but at least we get money. So for those who joined later, this application, what I'm showing is that if we come to this conference, it was raining, we bought policy before, and when we are, wet, there is rain, we get money for taxi. So that's how it is. And the TE extension machine checks from the Open Weather Map API data. It sees that, okay, there was actually rain, and you get the payout. So that's short. I mean, maybe not so short from code perspective. I have a couple of slides, but then I will open for questions or recommendations. I hope it made sense. I'm not going over everything, and we have worked for this for a while, and everything is Dockerized. So there is like what I mentioned, T proxies, T extensions, all that is Dockerized, and we have guides how you can start writing these T extensions. So you actually don't need to worry about everything. And later on, we are working with Google Secure Cloud. So this is the first partner we are partnering with, where you could deploy the T extensions, T applications, and we have multiple guides, multiple information how to deploy applications, and everything is still in development. It's on testnet, so it's fresh, and I'm happy that it worked today. So let's go back to the so here's the link for the demo, but I will post that on my X later as well. So you can find under Flare Foundation GitHub as well. And the time what I have left, I want to quickly explain what could be even more developer use cases, because this relatively simple application what I showed, it just goes and reads the information from API, and you are encoding this API key, which is not visible. But there could be even more use cases, like for instance private DeFi applications. Like you have some kind of risk scoring, which is only you don't want to expose it. It's your tactic. Some kind of specific logics, like private routings or confidential portfolio checks. You need to go and check to some kind of API, or real-world applications. Though that's actually very important as well. So you have some kind of maybe land registry, or like state systems where you can verify that this information is actually true. So how we verified if weather, what was the weather information. Like regulated applications, for instance, like I explained, there is like compliance checks, and you don't want to expose sensitive information. For instance, people's age, people names, whatever it is. You just need to check if they are, for instance, citizens, or they own a property. So that can be possible here as well. Otherwise, it could be open, and not that we want to expose this information. Like data marketplaces, and very important, what we are working also, why we actually created this, and we are giving to anyone, is cross-chain automation or cross-chain communication. So we're working right now on cross-chain wallet, specifically with Bitcoin. So this is how you could control from Flare network, which is EVM chain, Bitcoin wallet. So you have the private key of the wallet, of Bitcoin wallet, and then you can initiate trades, you can read information, all that stuff, and the key is not exposed to anyone, only the code and proofs that you did something. And we call it protocol managed wallets. So basically, system protocol manages wallets outside chain, and I think it's very powerful, which could open even more eyes, in my opinion. And the thing is that all of this technology that I am showing right now, we are dogfooding ourselves. So basically, we're building products with this information, same APIs, same technology, and we are giving to anyone outside as well to build applications. And yeah, and I think there could be some security trade-offs, so which I need to mention. For instance, like the key, you need to handle like failure. Basically, the T machine could go down, it can rotate. There could be, you need to think about recovery mechanism, maybe some multi-signature approach, how you store this key. Of course, the T machine itself, no one can change it. Otherwise, the hash is different. So basically, you see that machine has changed. But how you handle like keys, what's stored there, like to wallets, for instance, that of course is still up to you. That's not the technology what solves this specific problem. Yeah, and another use case is attestations of some information, external data. Like for instance, we attested that weather was measured at that specific millimeters, and then we got a payout with this application. And that's it. We are before time, so if you have any questions, I know that lunch is coming up as well. But if you have feedback, you can come and ask now. Later, I will be available throughout this week in this conference today and tomorrow as well. And still, this is very new technology. And we think that it will open many doors because there is privacy approach in blockchain. So that's how we can extend our smart contracts blockchain applications, and it opens many doors. Either communicating with other blockchains, getting information from other APIs, writing to other APIs. I know banking, weather, whatever APIs, and everything is everything could be there private, and you relay back only the validity proofs, so you don't expose private information. And importantly, you can get more powerful machine than it is blockchain, because blockchain is very limited. It's limited by gas, what kind of computation you can you have there. So let's imagine you can run like AI model in this trusted execution environment machine, which is in private, only for you. You do the computation with this model, and then only have the proofs, I mean the results back to the chain. So I think in this AI world, that's very important as well. I will be working on this idea later this summer, so you can follow on my X as well. I will post what we have, because we have multiple ideas how we can jump in this AI field and in trusted way. For instance, especially what happened in last week with Anthropic thing, that now we don't have in Europe this nice model because one person, we all know who, said that you cannot export that. And I think that shouldn't be the case. We can do better, that everything is kind of in just couple of people hands that you can make decision in 10 minutes. And yeah, I think it will open those doors as well, especially in AI. And in real world applications, like I explained, I think this is the missing piece what was in blockchain. We have been talking about that for years, but here you saw a working demo already. So thank you. If you have any questions, then ask right away, don't be shy, or feedback as well. Thank you. Yeah, can you repeat for recording?
Okay. Sure. Is it working?
Yeah, I think so.
I don't know.
Test something.
Testing, testing.
Ah, okay, now it's working, I think.
Okay. So, my question was, I don't know, I'm not sure, I'm not here.
It is working.
Okay, fine. So my question is, if you can go through the process of how the Go script is executed and also the end-to-end scenario. So I fork your repository, spin up a server, and put everything there. So that's sort of confusing for me.
Yeah,
So
yeah, yeah, yeah. I get the point. Right now is that you run it locally in Dockerized containers. So I have Docker containers here. So this is it's very small, but this is the weather insurance. It has the database and the proxy and extension running. So those are different services. So I will I will explain only about the flow. So basically, from front end, you start buying the policy. Let's go step by step. And how you run it right now, we have a repository which you can clone, and then you can set it up. There are guides on our dev hub also how to set it up. And I will be actually publishing about this specific use case most likely next week. So about this weather insurance as well. So there will be a guide how to run it. And how it works is that so you have a T extension running locally, but later this year we have guides how you can deploy to Google Secure Cloud. So there you can will be running this extension. No one can touch that one. Right now it's in testing phase, as I explained. And how it works is that we specify here the policy parameters. Then we call the smart contract. And smart contract has, there is T registry on blockchain where all the Ts have been registered and their hashes. And pretty much that is, here we have System Explorer as well, where all the T machines are set up. So and, I'm working with this specific T machine. And then as TE, it processes these actions in a synchronous manner. So basically, it sits and waits, and then see, oh, one action came in, I will process that one. Then I processing that. I'm doing some magic. In this case, let's say I'm fetching the weather information. I have that one. Maybe it takes 1 minute, maybe 10 minutes, maybe 20 minutes. And then it relays the result back to the proxy. And then you need to actually fetch from the proxy that specific instruction has been finished because you have the ID when you send to the registry. And then when you have the result, then you relay this information to the chain. This was the, I explained that you see that these signatures match. Otherwise, if signatures don't match, someone can sign this information from different T, different machine, whatever. So you need to see that this information match and this is correct how it is in T registry. Because when you set up everything, you actually registering your T in T registry. We have a network level registry of all the machines and all the hashes. So that's the validity, integrity check how it is. It's not like sending out in the void. And then once you process that information, there is actually no specific need to send to the blockchain. It's just how the blockchain applications work. You have the proofs on chain. So this was the what I explained with how we store information. We don't expose these weather millimeters, but we have the hash of this policy. And that's the kind of the privacy aspect. So it's up to you how you store this information on chain, right? So yeah, so that's essentially it is that you through registry you send this instruction, then it's being picked up by TE in a synchronous manner, and then it's the result is relayed back, and then you fetch from the proxy. So yeah, I know maybe this is. Hope that's working. So I hope I explained, and all the guides are there. We have very simple sign extension guide on our dev hub. It's updated, it's up to date. Basically, how you can sign information, and pretty much you can, I know, commit to GitHub or something. You have GitHub key in this TE. So that guide is up there. I will be adding this guide later next week. So yeah, I hope I answered that question. Of course, this technology, per se, it's not easy, but we are hiding away because we are making it Dockerized everything, and you can spin up Docker, so you don't need to mess around. Actually, developers, you can read more what's behind the scenes, but you need to be working on extension code itself, and everything else is Dockers. Of course, it's not simple, but it's relatively straightforward how it works. But of course, I would like to get feedback if that guide is, understandable, because I want to improve that as well, all the flow. Yeah, good question. Thank you.
Thank you.
Any other questions, comments? Was it kind of clear? Maybe I want to ask audience: are you exploring trusted execution environments or private execution yourself? What's the theme out there? I know. Maybe show up hands who are like exploring trusted execution or private execution outside blockchain. Anyone? Okay, I see some hand. Maybe you can give.
Yeah, so we have our own solver infrastructure. So we're trying to like create an environment where we can do private swaps and stuff because we see a lot of value there. So yeah, I mean, a solver like touches so many infrastructure points from relays to swap environments. So we want to see like could be a hybrid environment where we use tight TEs for certain aspects and like ZK stuff for different aspects. So yeah, so
Yeah.
we see value for TEs for certain aspects of a model, but like kind of like
Yeah.
ZK kind of execution stuff for privacy elements for different stuff. Yeah.
Yeah, I would say this. Yeah, it's a bit different than ZK because this is private compute. So you get actually compute, and that's the essential. So we need to think about these machines because here was just simple example, but you can have maybe running some code for I don't know, half an hour, AI model, or maybe even more. So it can be such and you cannot get that on blockchain. You cannot get even a couple of seconds pretty much of execution, and this is how what opens doors, in my opinion, as well. This case, because we shouldn't limit ourselves just a couple of minutes. Of course, you pay for compute time. That's like obvious. For machine, you need to pay, but you get the proofs and you get the security aspect of blockchain, because all the network is still validators are proving that these instructions are valid. So yeah, I definitely would like to see more use case how you would use as well. Thank you. Anyone else, or we're ready for lunch? I guess that's it. Thank you for coming, and if you have feedback, then catch me later. And have a great DappCon. Thank you.
Thank you.
Hello, guys. Oh, wow, this is loud. I'm actually loud, so maybe I should just keep this a bit further. Thank you for joining. Such huge numbers, I'm impressed. I'm honestly impressed, I'm not ironic. I know there is a little attendance at these things, but I think it's nice because it's a lot of people that want to build stuff, so welcome and thank you for coming and listening. We put already the dashboard up, so as the title says, we're going to talk about live data on-chain coming from Gnosis Pay. And I'm curious, does any of you use this Gnosis Pay? You guys? Yeah? Nice. Have you had any recent activity in the last 30 days? Will we? No. Okay. Then you're not one of these guys here. But yeah, before I start, to give you like a very brief context, we at Dena do data engineering for crypto native teams. We have worked mostly with MakerDAO or Sky, as you might know it, and we have covered a bunch of things from governance operations to payments, treasury operations, whatnot. And we realized there was no one single source of truth for data. Obviously, like we had a bunch of queries on Dune and so on, but we couldn't look at everything. And I always found this interesting, like we are living in this space where everything is verifiable, yet we cannot all look at the same source of truth and comment on it. So we started building this kind of dashboards. I think they have two types of usage. One is for transparency for the end users, but I believe these should be a must-have for any single DeFi protocol out there as well. Yeah, because it can help you a lot with alerting whenever something weird happens. You can catch those quite easily. So yeah, we started from the fact that obviously Gnosis Pay writes every single card spend, safe top-up, IBAN transaction on a public chain. So there's a million of transactions. They're all permanent and verifiable, yet there is no real-time watchable from outside their team. So yeah, this is what we are gonna cover today. Obviously, the proof is on-chain. It's effectively invisible to anyone else. And the fix, in our opinion, is not another internal analytics tool. It's a public proof of work, a ticker where you can watch all the transactions as they land, rolling counters, and the point is to make all of these visible for the users. We don't have one feed, but two feeds in here, and obviously we can build further, but we wanted to differentiate between the first part that's mainly live spends and the funding side. And the reason for this is because we are looking at two different user types here. And while we are not going to do a lot of live demoing today, we just want to walk you through a bit, like what was our thinking around it, how did we, where did we start, right? Like where did we start to have all this information, as well as touch a bit upon what kind of friction points or pain points we discovered across the way. And as my colleague Pixel did most of this work, I think it's more than fair to let him talk about it. So I'll hand over to him to walk you through the dashboard.
Thanks, Abba. So first of all, I would like to start with what was the starting point for this dashboard. So every one of us sits on X and is reading a lot of tweets about card processors and so on. And there was that strange tweet where someone wrote that one of the biggest card payments had huge volumes, and he knew no one who used that card provider. So we thought that it would be interesting to see this like in real time. And this is like, this graph shows you like what were the card payments in the last hour. And we see that we had like 367 transactions with a total amount of almost 60K, and there were 305 different users. All this data is read on chain based on spend events emitted by Gnosis Pay spend model. Also, so this is the first row here. And below we have like the volume of the user top-ups of their cards, that which are also is open data from the Gnosis chain, which were based on the transfer event that entered user Gnosis account. And we have here like some table with latest funding. We see that these events are not quite frequent. We have like 10 in the last day. And yeah, here is the current live data from the last hour. So we can see on each of these rows like the currency breakdown for all users in the last hour. So to make a small summary of the first part, so we have two surfaces that we are looking into this feed. First one is lifespans, and the second one is funding, meaning where the money came from. And these sources are classified by IBANs, or they are labeled by cow swap, top-ups, or bridging from other chains or the same chain. Like we can, I think I can show you here. Is more. We see that the most of the top-ups are like IBANs. But yeah, if we dig a bit in the history, we will see that, for example, this transaction was a top-up using Li-Fi bridge. Okay, let's wait for it to load. Yes. Yeah. So this is all the event history. So this wasn't a cross-chain swap, but it was a Li-Fi bridge from the Gnosis chain. Okay. And yes. Okay. And now I will walk you through the architecture of this small dashboard. So we have, first of all, Gnosis chain, where all the events are published. And for the live feed that you see on the screen, we are collecting the spend events. And we are using Envy Hyper Client in order to make the sync into our database. We use for this specific demo, we used a Supabase Postgres database. We have our own backend in Next.js, and we use it in order to aggregate the data which we are displaying in this frontend. And of course, in order to display data, you are interested mostly on the data on the top of the chain. So the data, like for 2 days ago, is unchanged. For this specific exercise, we didn't took into considerations reworks, chain reworks, because each of those spend events, even if it gets in other block, it still remain on chain, and it is subtracted from the Gnosis Pay user account. And yeah, so as I said before, the main part of our dashboard is the indexer, which looks like some big part of infrastructure, but it's not, because the hyperclient from the Envy covers almost all our use cases. And we use a cursor that is picking the latest block number from our database table. And we just sync the data that we are using for displaying live changes only after that specific block number. And yeah, maybe I should explain a bit about the spend event anatomy. So usually the data that you can find on chain contains 4 fields on the event. One of those is the asset, which can be the equivalent of euro or USDC or USD or GBP. And if you look at the dashboard, you see that most of the transfers are like euro, this blue tiles. These green ones are USDE, and this yellow is the GBP expense. So GBP, for example, is quite rarely used or was used in the last hour. And one more thing is that we are filtering the data from the blockchain based on event signature and not the emitter, because from the last security incident with the delay model, we woke up in the morning and we saw that we see no transactions on the chain, and we understand that, okay, we all know what happened, but at the same time the contract that emitted these transactions was changed, and we just switched it. And yeah, this is how the data gets in our system and is displayed on the surface. And yeah, so some facts about the event. So on Gnosis, each block is produced once in 5 seconds. So the speed of writing the blocks is not so high. So you don't have to maintain like a highly performant infrastructure. So for our example, we use the free tier of NVO hyperclient, a small micro Supabase instance, and a Vercel serverless architecture. So it's doing it work. Let's say on a very cheap cost. And yeah, maybe, yeah. I said about spend architecture. We can look into the logs here. So yes, this is the spend event. You see, this is the asset address. This is the account that spent the amount you saw before, and this is the vault. One important thing about the on-chain traceability is the fact that you see the user that did the spend, but you don't see where those money actually, you don't see the merchant exactly. And yeah, because all this spend get into some centralized Gnosis vault, which is forwarded further. Okay, so let's go back to the, yeah, and we already saw the recent fundings. So these are top-ups of the user accounts. How we are collecting, or how we are monitoring this type of events. So we are looking mostly for the transfer event on the chain, which has as a recipient one of the Gnosis safe addresses. Currently, we are monitoring all the transfers and just filter them by destination, but you can do this using hyperclient in a more efficient way, just by filtering directly and not looking into each transfer. But at the current volumes and our architecture work just fine. And relating to the labels of the top-ups, so these are not some labels that you can get from the event. You have to manually take each event, and based on the event log, you can classify them. So you see that here we have mostly IBANs, but there are also some events that are classified as others. So this could be just a transfer between two Gnosis users. And yes. And for these things, so that the recent funding are like quite rare events. And in this case, we used just some cursor that is just expanding by interval. Like in this case, we have 24 hours, 7 days, or 30 days. Which, and you see the frequency of the funds is like 1 in a few hours. So in this case, you don't have to make like very frequent polls in order to read 1 event per hour, which is not the case for the live spending, because these events are like can be like a few events in a single minute. So we poll once in 15 seconds. But this can be done even more frequently, but I don't think it makes sense to make it more frequently than 5 seconds when a single Gnosis block is produced. And as I've mentioned before, we are currently looking for the funding only on the accounts that already did some spendings, because we have the spend account in the spend event, and you just filter the transfer events with the destination of that account. Of course, we can do this even for the users that didn't made a spend anytime based on the account created event emitted by the delay module. And yeah, this will expand the funding events a bit more, but not by a big margin. And yeah, I think this was most of the architecture that we described. So yeah, on the front-end side, we use like React with recharts for these charts, but in the rest it's basic React components. And yeah, so I can try to do a quick summary on the architecture. So the indexer is just a watermark loop. So you always pick the new events from the top. You don't have to reiterate over the events from the last hour each time you do this update. And the labeling for the top-ups is something manual that we are just taking individual events and just look up for the path from where those funds came from. Yeah, I think that's all on the architecture side. I can show you so all this code which is extracted from our production code, you can find in a repo, which I guess is in our presentation. Maybe I can switch to it, but it's on the Gnosis Pay Monitor GitHub account. Yeah, so as a final thought, so the proof of this activity is always on chain, but it's not always displayed. So in order to see this so the transparency is there, you just have to build a tool to see it. Yeah, so if there are any questions. Yes, please.
How do you monitor the refund? So let's say if I pass the card,
Yes.
and then the transaction is reverted
Yeah. Yeah, you have some events on the vault that each spend event is sent to. So you'll see that most of the events are like out or are in that vault, but you'll see like some outflow events that can be refunds, can be cashbacks. Yeah, we didn't include this in this specific dashboard, but we looked into it. Well, another question? Okay. Yeah, the GitHub repo is on the screen. Also, I think I've forgot to mention about the pricing. So we saw that all the pricing we displayed in USD. We don't store that price anywhere. It's just live feed data from CoinGecko, and we just transform that on the fly. Yes. Yes, let me switch back here.
How do you differentiate, like, how you tag IBAN and not just a simple transfer? I see some transactions.
Yeah,
you the token. Is that the?
Yeah. It's just Monero minting one of those free tokens.
That bit of labeling is something that we do, right? So if it's Monerium, we know it's IBANs. If it's cow, like the labeling is a categorization internally that we put on top of the data.
I can show you here. So this is like a more static dashboard, but you can see here are like some types of funding. We see here that we have like DEX fundings or Monero, which are like those IBANs that you saw before. We see cross bridges. There was at some point a big activity on swapping funds on CowSwap, and yeah, there are also a lot of different fundings, the types of fundings that we just didn't label before, and yeah, you can see here like this is the entire history. There are like 3.3 million of spend events overall in the history of Gnosis Pay. They have different, so almost 38K users, but you can see this spike in new users when they switched the user addresses after the recent incident. So, yeah. Also, we have another small dashboard which just monitors the Gnosis treasury holdings. So you can see these holdings and also have a separate tab with the allocations in different protocols like Spark or Balancer. But this is static data. We don't monitor it real time, and I don't think it really makes sense to have it like 1 minute breakdown for this. Yes, another question? Yeah, thank you.
Blinding. Hi, everyone. Thanks for showing up. Okay. to my cypherpunk roots. Before that, I did like various hacking for NGOs, cryptography, and so on and so forth. Then I had my company time, and then after I exited the company, I was looking for things to do that help the ecosystem. And then a good friend of mine, Jaromil, a hacker that I know for like 20 years, and that was working with various Linux distributions, and which I also was part of, and was also always connected to the hacking scene in Italy, called me, and he didn't call me in years, and I saw the phone ringing, so if he calls, it must be important, so I picked up the phone, and he said, hey, you got to come to this thing in a few days in Berlin, or near Berlin, and I'm like, okay, I trust you, and there I was, listening into all the talks, and also connecting to Brewster Kahle of archive.org, personal hero of mine. I was like, oh, cool. So Brewster was there, and he expressed specifically the need for a program or a package that has the software to access the decentralized web, but also to write to it and bring it all in a very easy packaging. And I was like, okay, that must exist, right? Or like some components you can just stick together and that's it. And so after the camp, I researched a little bit and I realized it's not really there. So there's like fragments of it, but there's no easy-to-use interface. And then I thought to myself, maybe a browser is a good idea to kind of connect it all, because it's the window to the world. And I always like repeating that Victor over there told me, don't build a browser. I know he meant it differently. He meant it's very complex, and it is complex. But these days with agents and AI-assisted coding, like a two-people team can build a browser, like conveniently, right? And that's what we did. And we connected all these things. And now, 6 months later, we have a fully functional browser that, even though it only exists for 4 years, for 4 months, 3 months, in the public eye, already has a name for itself. So there's clearly an interest and a demand in a decentralized web interface, and that uses the same usability as the existing browsers, and you don't have to start a separate node or connect through a gateway and things like that. So that was the original story. And I will just continue with the presentation then, if that's okay. Video team? Yeah. Cool. Oh, perfect. Now we can start. So here we go. Yay! And I hope you're not pressed for time, everyone. So yeah, the DWeb is very easy to read coming from a traditional point. You can just go through a gateway and read DWeb content, but that kind of defeats the point. Right? You go to .limo, .eth.limo, or .link, or whatever the name of the gateway is, and then you can access the decentralized content, or that's decentralized host that has a decentralized hosting. But that's not really what this was supposed to be, and so. To go further, to read it directly from different nodes around the world is one thing that we did, but then in the second iteration of freedom, we are also allowed to write to the DWeb. And with it came the owning part. So read, write, own, that's all built into the browser. So by downloading and running the browser, you are part of the network. You're not just a consumer, you are like also a publisher, a producer at the same time. And that's actually what the original internet vision was, like many publishers, like a peer-to-peer publishing. Build your website on your own computer at home, host it through a modem line, or put it on GeoCities if you want. That was the original vision, and that's how I grew up with the internet. I did this as well. I built small homepages in the 90s. And then it became more and more centralized, and with centralizations, obviously there come a lot of issues that are not in the interest of the end user. You have like monopolies that try to charge you for things or try to exploit your data. All these sort of things, you don't want really, but often you don't know that they're happening. And that's why I think it needs to come back to a more decentralized approach of the web to, in a way, save it, because these big silos, data silos, are kind of governing the web, not always in the interest of the user, or mostly in the interest of profits, obviously. So that's where this came from. And just for this workshop, if you want to set up now, I don't know if you can read it. It should be okay. So as I said earlier, you need a Git account, or sorry, a Git setup, and you can just clone the repository. I don't know if you can read it. So it's solar development, -xyz, /freedom-browser. If anyone can't read it or needs some help with that. Okay, yeah, stay in the middle. Stay in my lane. Meinhard, stay in your lane. Don't diverge. So once you have cloned that, I hope like Git should be open on the network. If not, then we have a real issue. You type npm install. So you change to the folder, obviously, type npm install. And that runs through, installs a few libraries. And yeah, it's nothing out of the ordinary, pretty standard stuff. So then you can run npm run and download, and also IPFS download. What this does, it downloads the peer-to-peer clients. We don't ship them with the browser because they change often, and also they're quite big binaries. And yeah, so we separated that from the source code itself. We don't keep them in the repository, obviously, because they're just binaries. And so the first one, Ant, is an interesting part, and this is the world premiere of Ant. It is our own implementation of the Swarm clients, Swarm peer-to-peer clients. We used B before, and B is amazing. But for being portable on different platforms, including mobile, and also for us to quickly implement a feature that we want from the network that is there in the protocol, but that's not exposed by B or not in the way we kind of want it for our mobile apps, we decided to vibe code a Swarm client. Also, and then when that was going well and progressed quite fast, we also decided let's do the same for IPFS and re-implement the whole thing as well. And almost in every aspect, the IPFS client is faster than Kubo, which is the official, more or less official client. It's faster, it's smaller, it's leaner. It doesn't keep constant connections to the network, peer connections. It only opens connections to the network when it downloads a file. So it's very lean on the memory. And yeah, so because it's very fast in connecting to the peers as well. It keeps a warm peer set and kind of can just connect within a second to 50 nodes or something. So it doesn't need to run all the time in the background. It can be started on demand. And a similar thing we'll also do with Ant, where we launch it and kind of let it cool down, let the nodes disconnect if we want, especially on mobile, where resources are limited. There's going to be a more permanent mode on the desktop computers, but on mobile, every resource is very scarce, and also the apps are being closed anyway by the operating system. So we need to be able to quickly reconnect to the network, and that's what these things do. And yeah, once you have that done, you can do npm start. And I know I'm not supposed to, but they're not there, they don't see me, to leave the camera, but because this is a workshop, I'd like to see also what you want. Installing Git. Hey, is it yours, Anna? Cool, nice. 10 hours. So who has the repo cloned and npm install run? Is anyone on that, or any issues with that? I mean, I can just also continue and show it on my computer, but these slides are available, and that's the last step actually here in the workshop repository, which is github.com/meinhard with 2R /DappCon-2026. The slides are there, so you can always come back to that and do it later at home or whenever you have time, or in the office or in the train. So all the slides are there, and also the examples that I will give later, they're also in this repository. So yeah, you can just clone that later. And also I will publish it somewhere, I don't know, maybe on LinkedIn or something. Or also on freedombrowser.eth. So once you have started Freedom, it should automatically launch the nodes and connect to nodes. So with Ant and also with IPFS, so IPFS actually doesn't connect to nodes. It's waiting for a job to do on the IPFS network. But with Swarm, it connects to 100 nodes within 1 or 2 seconds. Yeah, so yeah, once that's done, you can open freedombrowser.eth, and that's already showing the magic. So you have like a native resolution of ENS names. So this is not using the more or less centralized DNS or centralized authority DNS. It's using ENS, which is a smart contract on Ethereum. to resolve the names. So freedombrowser.eth will translate to a content hash or to a swarm hash, and then Freedom uses this hash to get the content from the swarm network directly from the peers. So there's no gateways involved in this. The name resolution is a bit of a half centralized part, and that's really still one of the biggest issues we see in terms of centralization or decentralization, that ENS or Ethereum clients don't really have a light mode that's practical to use and to ship. So that's something definitely we are working on. We're trying out different solutions. We use as a backup also a quorum of different RPC endpoints, so we don't trust just one computer to give us the right answer for an ENS name, but we query several and then we compare, and if they agree, then we forward to the website. So it's kind of limiting the risk of being hacked. But first we do actually another method that's sort of a light client. So yeah, we have different layers of security in the ENS resolution. So once you have that set up and it's all connected to the browsers, an interesting thing you can do, or I will show it also on the screen, you can create an identity. So immediately it's almost like a profile, but it's creating a private and public key pair, which you can then use for authentication for websites or for authorizing money transactions, or even to publish content on the decentralized web. So it's kind of one key for everything. Yeah. So it's totally optional. So it kind of gives you more powers, but it's an optional step, exactly. So yeah, those are the repos. And if everything works well, you should see something like this with nodes connected and yeah, kind of speaking to the network. And as you can see here, the IPFS doesn't have any connected nodes. It really just says the jobs that it worked on. By the end of this workshop, if you have the setup live, you will have published something to the decentralized web. It's quite easy, and yeah, I will guide you through the steps. So it's very easy to connect your identity via the known window.ethereum API or interface. Then you can create content, you can publish it, and you will get a BZZ reference because we're publishing to Swarm. And you can also sign messages cryptographically, all within the browser without any extension. So, and then later you can resolve or tell ENS which content hash to use for your content. So you get that link as well. So yeah, the browser really is the bridge between the applications and the networks. And yeah, so it's all happening on your local machine. That's sort of the magic in that. And yeah, so you can, as I mentioned already, have an identity for signing and permission management. Then window.swarm, that's where we expose direct access to the Swarm network. So it's just a JavaScript object that you can speak to, and you can publish content, you can retrieve content, you can yeah, update feeds, which is a feature of the Swarm network. You can retrieve individual chunks. Every Swarm content is chopped into small chunks of 4 kilobytes, so you can get just one chunk if you want and analyze it and do stuff with it, or reassemble the file as you wish. And also it has native protocol support for BZZ, IPFS, and ENS URLs. And yeah, so they are very native to the browser. So they have their own local storage. They function like normal website objects, or like host names almost. And yeah, by that you can then use a BZZ reference for addressing and access the content via the Swarm node. And this is all familiar on purpose. It's a bit small here. I don't think I can make it much smaller, much bigger. No. So it mimics to some extent what extensions do in the browser. So the window.ethereum functions the same way. Florian implemented this to be kind of a drop-in replacement for MetaMask and other injected wallets, and it functions the same way. Every web page that's compatible with MetaMask and other injections is also compatible on Freedom already when it comes to the Ethereum link or the Ethereum identity. And the window.swarm, that's a new, well, a sort of standard. We proposed also a standard regarding this to make it available for other applications to implement. And yeah, so that's the familiar element of this. So it's the same request pattern as in known APIs. So we'll in a second upload something, something small. And just before we do that, a quick notes on how this happens. It runs through the local node, as I mentioned already. And we have a small sort of tool website in it, which is freedom/publish. And that's yeah, a small interface to the publishing, very low level. And there's a concept of postage batches and stamps, and you don't need to understand all of these right now if you're not familiar with Swarm. It essentially is a way to pay for your space on the Swarm network and also for the volume that you consume when you transfer files in and out. And yeah, there's also a stamp manager that we use. And to make this all happen, you need the BZZ token and also the DAI token. This is the currency of the network. That's not transferred directly on Swarm, but it's transferred on Gnosis or maybe on another blockchain. And the messages are passed back to the Swarm clients. Okay, I have paid for this, so you can give me this content on a different channel. So it just outsources all the payments to real blockchains. Swarm is not a blockchain as you know it. It's a storage. It's a distributed hash table with content chunks addressing. So yeah, today, if someone wants, I can send some of these tokens to you, and then you can try it on your local systems. And the signing doesn't need any gas. If you sign messages, it's just cryptographically signing, and the website and the JavaScript in the website can just request that. And in production, obviously, you would have your user fund the apps by themselves, and there's different ways of doing that. There's bridging, there's swapping, and yeah, the idea is to have a very easy-to-use interface for that, but that's really on the application developer's side. So for the first hands-on part, so publishing to Swarm is in Freedom is rather easy. It comes with batteries included, and once you have set up your identity and you have set up a wallet that's, or let's say, funded your local node, you can then publish. So that part, the funding on the local node, that's a little bit of a process right now. We're also working on making that a very seamless one-click solution, and we have that also in some test branch, but it's not live on this system yet. So yeah, let's just do this maybe directly on hands-on. And also in the repository, in the examples, this code is available. As you can see here, it's no rocket science. It asks for access from the Swarm client in the browser, sorry, and then it uses that object that it gets returned to publish data. So there's a method called publish data, which accepts data and the content type and the name, some metadata, and the rest it does in the background, asks the user for permission if they haven't given permission to do this autonomously. And then it just gives the reference and also builds a URL that you can directly type into the browser later. And yeah, let's just do that. And the things I just talked about, it's a bit small, everything here. I hope you can see it. So we are on a page, and sort of an easy way of entering commands here would be to just have the developer tools open. So you open the console, and here you can then go and say window.swarm, and it will give you an object, or yeah, which has all the methods exposed that we talked about. And to get permission from the website, let's make this maybe smaller. Yeah, we can just do this here, paste it into the console. And because it's already pre-approved, it doesn't show any confirmation. But if I do that again without the approval, is this visible? Okay, I'm just going to make this a little bit bigger. I can't even read it myself. So what happens now, we have a sidebar here, which then asks the user, hey, do you want this website to access your Swarm API? And you say, allow here. And then the object returns, or the request returns an object that you can then work with. So, and next thing will be this call to publish simple HTML. So we just paste that here, and we say hello Berlin. So it's very simple. I mean, it's not even a HTML page. Oh, we don't want this. And we just enter that, and then the browser asks. So we're kind of mimicking to be this website in the background, right? So that's what's happening. So the website could call all these JavaScript functions as well, but we do this just to the console to be more flexible to edit it directly. So and then it says, do you want to use this? Do you want to spend some money on this? And I can just say always allow. And then what happens here? It returns nothing right now, but it has filled these variables here, reference and the BZZ URL. And yeah, we can just console log this, or actually reference. So this is the Swarm reference, or the Swarm hash that we got back. And what we can do, we can just put this directly into Swarm, directly into Freedom, and it shows us the content. So, and the page source, as you can see, is exactly what we did here. And if we want to verify that this is really live, we can go to a remote gateway. Let's say, so, and I also deployed something here on as a gateway. We can first get the info. So it says it's hello HTML and has website content. And we can also open it, and it says hello Berlin. So this is a gateway that's running in a data center in Germany, somewhere in France, sorry, in Frankfurt. So this has also picked it up from the peer-to-peer network. It has already broadcast this information on the peer-to-peer network and is already available over there. So yeah, that's the publishing through JavaScript. And what you need for that is first of all, the identity here. You can see here it's the main wallet. It has some XDAI for gas. And then you also have the node. The node has a separate wallet and a separate balance, currently almost 20 BZZ. And you need that to buy storage. So first you have to buy storage on the network, or kind of reserve storage. And then you can use that. You get almost like a receipt or like a permission slip to use that storage, and you give that when you connect to the node and when you send out the content. So yeah, that's the setup here. So I mentioned earlier also the freedom publish feature. So here you can just publish a small folder, and we can go to the repository where there's also some examples. We can publish the mini app here. And what the mini app does, it gives a bit of an interface to the functions I just talked about. And yeah, you can see this was almost instant because it's very small data. It published this little website, a few kilobytes, instantly. And I also have had pre-approved the publishing, so it just did it without asking me. So I can open this now in a new tab. And you can see there's a new hash here, which again I can also check in a normal browser, and it will show the same website, but it will say window.swarm not here because I'm here now in Chrome, and Chrome doesn't have obviously the functions that we need for this. So here, this is the same thing. We can give a title, hello Dappers, and yeah, this stuff. We can add a smiley to it. And here, because it's a new page, it asks for permission again. We can connect it, and we can then say publish and sign. And it gives a bit of details here. We allow that. We then publish. And I have to unlock the wallet because it's signing the message. Exactly. So. And I can do that because I set it up with a fingerprint or with the Touch ID. I don't only have to put in the Touch ID. It's signed, and here we go. It's now also open Yeah, so hello Dappers. It's another piece of content we published, again, just text content, but we can do the same thing with images and videos, everything. So yeah, that's very simple publishing, done on Swarm. And let's go back to the presentation. So yeah, there was no server involved. We didn't have to sign up to any publishing or any hosting provider, and still it's available on the web and in the coolest way possible, the peer-to-peer way. And we got the reference back, and we could open it in the Freedom browser. And the reference is the identity of the data. So it's definitely unique data. So this still says Kubo. It's a bit outdated from this morning because as of today, we don't use Kubo anymore. We use our own Freedom IPFS implementation. The writing part for IPFS is not implemented yet, but we plan to do the same thing as well to kind of give the people the choice and also experience the advantages or disadvantages of the networks that are there. So we already did the authorship, that you can sign content before you publish it. This is interesting in the context of person or man-in-the-middle attack, where you could, on the fly, change the content of a website, for example, to sniff some secrets, sniff some private keys, or change public keys to steal some crypto. So that's where signing comes in. And we just did this also, where the browser gives an interface for signing, and again, the code for this is also in the repository for this. So from hash to name, so we have gotten these hashes, these codes from the published content. For example, here this one, and what we can do now is we can link it to an ENS name. So you go to an ENS provider. You can also just talk to the smart contract directly, but there's an ENS website where you can just conveniently do that. That connects to your local address, to your local wallet to authenticate you, and also to pay a little bit of gas and a little bit of fee for the update. And of course, you have to first register this domain name. So minehut.eth is one that I registered, and we can then go to the you see ENS domains. It's very small, but this is the centralized website, but they also have a website live on, I think it's IPFS as well. So what we can do now is for dappcon.freedombrowser.eth, so it's a subdomain of the freedombrowser.eth domain, and we can go and edit the records. And in other, we have the record that's called content hash, and that's really the part that links your content hash, the thing you just uploaded, to a name. So we can just paste the content hash here, but because it's also protocol aware, we need to add BZZ before, and then we can save it, and then it's opening a wallet, the wallet to confirm. So in this case, MetaMask, and here I just confirm. And what it does now, it updates this record on the Ethereum chain, and then it's available for lookup by ENS resolvers, and this takes a few seconds. But the result later will be that we can type this human-readable domain, dappcon.freedombrowser.eth, into Freedom or any other browser that runs on a gateway or that uses the gateway, and it will bring us to the resolved content, and so we don't have to remember the long hash, but also the hashes can change all the time, right? If I update the website, I don't want to have a new website name all the time. It's the same way as DNS also works. So transaction is successful, and let's do this, and let's go back to Freedom here, and type it here, and now the big effect. Yay! So we've resolved the ENS name in real time. So if we want to know a little bit more about how this ENS name was resolved, we can check here. And it gives us the content hash that it was resolved to. And if we compare it, it's the C033 to what we had earlier in the console. The C03, it didn't show up here. No, it was another content, another thing that we did here somewhere. here, C033, that's the one that we got, and the website is resolved to that. So that's how you link it, how you publish your websites. So that's the basic to publishing. So we also, and I showed already, have this mini app, and you can publish whole folders. I also showed that. Did I show that? Through the publish interface. I think I did, right? I forgot now. If I already showed this one, was that the folder? Oh, yeah, this is the web publisher. So this is a whole folder on the local machine, which you can see here in the mini app. So that's the code, and essentially that's uploaded, but just by dragging and dropping it into the browser. So very, very convenient. Okay, so check out the repository, and what you can do with this is quite interesting. So if your app wants to have permanent data available for everyone, you can do that with these API interfaces. So if you want to generate user content, so we do that, or Florian does that with SwarmIt, which is a decentralized Reddit. It uses exactly this JavaScript API to, if you write a post, you don't write it to a database, you write it to a piece of content or to a chunk or to, let's say, a content hash on Swarm, and then SwarmIt is smart enough to connect all these different pieces of content, small JSON files, and put that into a feed, and make this feed available through a smart contract on Gnosis. And that kind of brings it all together. It's emulating a database in the absence of, let's say, production-ready decentralized databases. The idea is that everything is sort of static data, so thereby it can be easily replicated across the system. And then you have also this feature called feeds in Swarm, where you have a reference that always stays the same, almost like an ENS name, but it can have changing content underneath. So it kind of resolves within the network to different content chunks. Another thing I didn't show, but which also Freedom supports, is 402 payments. So you can there pay for little content pieces on a website, and it's natively supported by the browser. So let me just show that as well. We have the I think it was somewhere. Let me find it here. It was on my website where we announced it. It was the blog. And so this is a small demo page which has parts of content that are insufficient funds, of course. Where if you have enough funds, you can just with one click unlock the content. And maybe I just top up this funds, so also I can see that. And it would be on the wallet part. Let me go to Base. So we have support for Ethereum balances, for Gnosis balances, and for Base balances. So if I just top up some funds here right now, what I'm doing now is I'm using my local wallet here to upload funds to the browser here, or to transfer it. And let me just do some XDAI. Oh, USDC, right? USDC on Base. Okay, next, let's say 0.1, and confirm. So what I'm doing now is I sent 10 cents, USDC cents, on Base to this browser here. And we should be able to see the balance very soon. We need a reload button here, so which we can press. It doesn't make it faster, but we can press all the time. Florian, we need a reload button on the balances. This way we can just hammer the button all the time.
Yeah, it's currently just checking
there
every
you go.
30 seconds or something.
Okay, so here we go. So we have the 10 cents. And what this does now, if we reload now, and you see this part is not readable. It's a content that's behind a paywall. normally what you need to do is you have to sign up for a subscription and forget about it, and then you kind of pay for it for a few years. And here you can just say pay once, and it unlocks this content for, I think it was, how many cents was it? Recent payments. This was 2 cents just for this one piece of content. It's a demo. Also, the content might not be worth it. It's some AI-generated slop. What isn't these days? So yeah, that's funnily enough the original vision of Satoshi Pay, the company I founded, where we had a micropayment paywall integrated the same way without, or actually partly with 402 about 10 years ago, where we did the same thing on Bitcoin payment channels, and it was more or less an experiment. But now we have a proper support within the browser and also in a wider ecosystem with the X402 standard that also Circle is pushing quite heavily. More for agents or agentic use, but yeah, it's for the website. It doesn't matter if an agent crawls the content or if a human looks at it. So that's the 402. And if you want to see how the 402 is done, you have the websites here. So the interesting thing is the actual content is just behind a HTTP error code, not error code, like a status code. There's no extra magic. It's really like the web server talking to the browser through standard HTTP codes. There's no other secret exchange. It's really just using that layer. So that's why we have also a server here, a small server that has these the headers, the X payment and the payment signature. That's essentially what we also imagined back in the days 10 years ago, but now we have it as a standard, and it already works in Freedom, and it's kind of just waiting for users. Okay, so that's the 402, and we also we're premiering like a new API that we will integrate soon, which is already kind of being coded these days. It's the navigator.freedom. So why do we go for this very old school navigator.freedom namespace? It really signals, okay, this is user agent owned. It's like safe on the user agent side. It's not injected by a website or by an extension. It really comes from the user agent. And it will expose different storage mechanisms, different feeds, identity details, payment details, and also ENS name resolution. And yeah, so that's essentially what's coming next. And it will make the browser into a developer platform. The idea is, of course, that we don't have this like isolated solution, but that we will develop this into a standard that other browsers can also implement, or other apps, to give direct user access or website access to all the decentralized elements or anything Web3, any payments, to standardize this further and make it first-class citizens in a browser. So just to kind of wrap up what you've seen how we linked storage and how we wrote to the network. And you already have the access to the source code, poke around in it, test it, spread it, and also publish your own website. You know how it works now. And if you have any questions, there's also a Telegram channel linked on our website, freedombrowser.eth. And so the slides are live. And feedback to these APIs and also the navigator.freedom is warmly welcome. And thereby, I think I can go to the question and answers part. Thank you. One thing I want to show. Some of you have seen this already. It's the mythosgame.eth. So what this is doing, it's a 3D game that I vibe coded, and it's hosted on Swarm, and also in the multiplayer mode, it's connecting to other nodes with peer-to-peer protocols. So there's like a WebRTC connection and sort of a coordinator of these WebRTC hosts, but they can all, once there's many nodes, they can all speak to each other, and it runs without a centralized backend. So yeah, you can yeah, just walk around, and there's a few other enemies. But if you go to the multiplayer, and if someone else joins the multiplayer right now, you will see that it's a multiplayer, and it uses GunGS, GunDB, which is sort of an experimental, decentralized data and messaging layer that we use. And is anyone joining for a deathmatch?
What is it called?
So it's mythosgame.eth. It's very small here.
But how do you connect to this particular? Sorry, how does the second player connect to this particular game?
And you can see now up here, you see the other players. Oh, there's already some people firing.
Oh, sorry.
So, and if you look at the what's going on the okay, I need to minimize this first. What's going on in the network? You can see how GunGS is heavily relaying messages. I think because I'm dead now, I don't relay any more messages. So, yeah, and it's sending it directly to other peers. There's no centralized element to this. I mean, there's one gateway or one peer that's always on, that's on the server. But as soon as there's two and they know each other, then they can see each other. So it's the world premiere of the first fully decentralized 3D shooter.
Could this virtual world live on Swarm?
It lives on Swarm. It's hosted on Swarm.
It lives on. When you load the game, it's a JavaScript.
Yeah, it's fully Java. So the cool thing is also
the world is not in the JavaScript.
it is in the JavaScript. The world, yes, everything is in JavaScript.
What I mean is like one shared world could be on Swarm.
No, it is already there. So but let's say the world, or what makes the world, is the people in it, and that is not on Swarm at the moment. It's a messaging layer that's independent of it.
What I mean is, if someone moves an object in this world, then the location of the object is beyond.
It's not implemented, but it's totally possible. I mean, like, an object is also another player. So the same way another player moves, objects can be moved, and the world can be changed, like Minecraft. This could be done. Yeah, I mean, actually, a cool idea to have like a Minecraft-like. No. As you can see, this is like real time, right? Where is it now?
No, I mean to store the state of the world on Swarm.
Yeah, it would be some sort of settlement every. Yeah, I'm eliminated.
Would be like
Who did
a
that?
feed that changes the world.
Yeah, I mean, of course, this is just, again, a tech demo. It's not a serious project that I like pursue, but it's just, yeah. This was vibe coded with Fable within 2 hours.
So can you do feeds?
What's that?
Can you do feeds like?
Freedom can do that, but that's where the performance part comes in. But yeah, we didn't try it on feeds, but I think it's possible.
So if you want a blog and you add a new post, then it would update the feed.
That's actually what Swarm does.
Can you show Swarm?
Oh yeah, of course. Sorry. Yeah. Yeah. Shameless plug by Florian. Not shameless. I plugged it already. Why is it? It's a new profile. That's why it's not there. So Swarmit is loading. So that was one of the things we fixed overnight last night, and we're kind of we give it a moment. This uses feeds heavily, and Swarm feeds, and Swarm feeds are quite complicated in the way they are being implemented, or like how a client, let's say our Ant, so this runs on Ant, doesn't have the full support yet for all the features, and there's a few edge cases that we didn't cover, but we're about to iron them out. Let's go. Say again?
I'm just want to do a bit of publicity for the new PubSub. protocol that's gonna come, yeah? So
Say again, the what?
so PubSub protocol on Swarm.
Oh, okay, it's coming,
native,
cool,
yeah,
perfect.
native.
Yeah, that could be the backend for this and also for the game and everything like that, if it's performant like that. Perfect, I didn't know it's coming, cool. Yeah, more questions or comments? Anything else that I should show maybe?
Or requests.
Post, yeah.
Feature request.
Oh, yeah,
Access control, ACT, cool feature in Swarm. If you could have that as an option when you upload.
Say again?
Access control, ACT.
Is it a feature of Swarm already, the
Yeah.
access control?
Yeah, it
Is that what we're using by with Swarmit? Probably not, right?
No,
Okay.
I'm pretty sure Ant hasn't implemented it. But
Can you put it on your list, please?
yes. Yeah. It was a piece of work to convince him to implement feeds. Reinhard is not a fan of
No. I'm not happy with the performance of them. So just static references are so much faster. They're instant because they're cached locally and they're there, and feeds are being traversed and looked up. And I need to look more into it. Maybe Ant can do something to do a few shortcuts. I know why. I can understand why they need to be slow, but they are slow. So that's why. So here I'm just publishing something on Swarmit, and I allow it. And then maybe I do this to allow everything. So what it does now, it takes the content, it publishes a few pieces of JavaScript, of JSON essentially, and so it chops up the post into different elements, and then posts it on the website. And once it's done, not on the web, on the Swarm network, and once it's done with that, it goes to a smart contract. And announces it there. And Florian, how do you call them? The coordinators? Oh, yeah, sorry. The coordinators, do you want to?
The curators?
Curators, that's what they're called.
Yeah, and you need to confirm.
Send all my money to Florian, okay.
Yeah, thank you. Oh, wow, Jesus. And another confirmation. Sorry, it's a one-time setup. So the secret behind Swarm, it relies entirely on feeds and uses Gnosis chain as a discovery layer for new posts. And then there is sort of an intermediary introduced to make this really efficient, which is called the curator. Anybody can be a curator, and curators are just building feeds that combine all the posts that have been announced on Gnosis chain and put them into a feed. And a user can just say, yeah, I want to view Swarmit from the perspective of curator ABC, and then they will pull the feeds from Swarm that this particular curator has prepared. And if they don't trust any of the curators, they can just run their own curator, and curators can censor content. They can decide to not include certain posts. So there is the ability to censor and everything, but anyone can run a curator, so in the end it's effectively trustless, and this concept of the curator just makes it much more efficient than if every user would have to traverse Gnosis chain events to sort of rebuild the feed stream for themselves. So that's sort of the kind of hack, how I build it. Yeah, I looked into Swarm Graffiti as well, which is a sort of hack, but yeah.
One more request is to have an interface for the erasure coding feature for the upload.
Okay.
That would make it more resilient.
Okay. We can look into that. If you mention it in the group again, or maybe you have some spec that you can point to, it would be perfect. So we have a Telegram group where we discuss all this with about 100 members. So you can always drop feedback there. I mean, if there's no further questions, comments, or feature requests, other than Peter's feature requests, then I'm happy to leave it here. And also, Florian is here I'm here for the next 2 days. There's going to be a talk tomorrow about the... oh, wow. I think it's time to go. We're breaking chairs already. The rest of the building might come down. Knock on wood. So there's going to be about the grand vision and under the big headline, Reinventing the Browser tomorrow by Florian about the backstory and also what's coming and the reasoning for freedom.
Can you maybe say something about the security implications? Can you say maybe something about the security implications? I was just trying to set up a container that could run it. It's a bit tricky.
Okay.
Yeah, because like this NPM based, there have been a lot of supply chain attacks. So
right.
And yeah, I have a lot of stuff on my computer. I don't want to be compromised.
A good instinct. So we are vulnerable also to supply chain attacks on NPM, of course. Not of course, but we try to mitigate that. Regarding Ant, the Rust-based implementation of the Swarm network, we have sort of a pinning to certain releases that are vetted, that we know they contain our code and they're sort of clean. But they're also just binaries to download. So that's one aspect. Supply chain attacks, we don't protect ourselves specifically. So that's definitely something maybe we can look into. Or the other thing is that we are using Electron as a rendering engine, or like Chromium as a rendering engine within Electron, and they are always, not always, they're sometimes a little bit behind 1 or 2 weeks, the latest releases. Also, it doesn't match with our release cycles sometimes, so you can be out of date for like 4 weeks, 3 weeks. In this case, currently, I think we're 4 weeks behind. So that's the thing to watch out for, that if there's zero-day exploits in Chromium.
Electron is behind Chromium. Yeah, exactly.
Well, yeah, Chromium. Sorry, Electron is the framework that gives us the app layer for like having a browser, and then the engine inside is Chromium. So that's why you have the fancy, and you will know this inspect. So that's the same as in Chromium. It is actually Chromium. So yeah, somewhere here it shows Chromium content. So that's one aspect. In terms of security, of course, so regarding the identity, that's stored in on macOS in the keychain. Is it called keychain?
So we generate a mnemonic with the same library that MetaMask uses, for example. But then on macOS, when you choose to do a quick setup with your fingerprint, we're going to store the password to decrypt the mnemonic, which is stored encrypted on chain. The password to decrypt it, we store it in your macOS keychain, which is tied to your macOS login. It's like semi-secure, I would say. It's not amazing. And I would not keep big amounts of crypto on the Freedom Browser wallet at the moment. But in principle, it uses the same level of security as a MetaMask would. I would think it's roughly comparable. Yeah, it's like a hot wallet. So, yeah.
So talking about hot wallets, so it's wise to as Florian mentioned, to view this as a pocket change wallet and not as your main bank, right? I mean, generally hot wallets have different purposes, but here the idea is also to lift a few security restrictions in how you spend it by having more convenience. And this is like how pocket change in your pocket works. You know, it can fall out. It's it's not a big deal if it's like €5, but you shouldn't have the same security for your your life savings, obviously. So that's a general security advice we have.
When you approve, when you approve spending, would it be possible to set a limit on?
Yeah, it's already in.
It's there.
Yeah. So there was a checkbox where you can set monthly or like a certain time scale for the content payment part for the 402, and for other things, I think it's not implemented this spending limit. But yeah, it can easily be rolled out to other ones as well. One more security implementation or implication: the nodes. IPFS and also the Swarm node, they expose local ports that are visible by all users or everyone on that machine. to upload, download, or even like spend the money on that node. So you need to be aware of that. However, we have with IPFS we have done it already. Yeah, so it's not exposing a local port anymore at this version, right? So it's essentially has direct function calls to the embedded node. So it kind of talks to it directly with, I think it's Unix sockets, I believe it is, or some sort of socket. So it doesn't expose a port. And with Swarm, so and our implementation is also doing that on mobile already, and we can also bring it to the desktop as well, so it doesn't expose a local port. The downside of that, you cannot reuse your local node, but since we're just a download-focused node at this point on the Swarm network and also on IPFS, it's kind of one-shotting requests anyway, and it doesn't need to be running all the time. So that's the security model that will change slightly in the future of Freedom. So now we have, 5:30. Thank you very much, everyone.